Good morning, good afternoon, good evening. We are back and better than ever, and we are going to talk about the shortest distance from a line to a point, which we all know to be the perpendicular distance. For example, from P to this vector, we would never, ever, ever say, oh, okay, that's how far I am from the line. That's the shortest distance. No, it is always the perpendicular distance. So, in this particular case, if I have a ship R that's sailing through point A in the direction of B and continues past the port P, at what time will the ship be closest to the port? Well, the ship is closest when the vector PR, now R is over there now, but let's assume that it was closest when, here we'll go pink, PR, right there, was perpendicular to vector AR. Okay, so in other words, when R was right there, when the ship was right there, that's when the ship was closest to the port. But it just kept on chugging away. Okay, and that's what this drawing is all about. We say that R right there is the foot of the perpendicular from P to the line, and of course this symbol is what we use for perpendicular. So we have three examples. Let's take a look. A line has a vector equation xy equals 1, 2 plus t times 3 negative 1. T's the real numbers. Let point P with the point 5 negative 1 find exactly the shortest distance from P to the line. So, just real quick, we've got a line, going through the three-dimensional plane, and we've got some points. So we are looking for this distance from here to here when it's perpendicular. So that's what is happening here. But how do we go about that? Okay, well, let's say N is the point on the line closest to P. Okay, so we're saying, like in our little drawing here, that this is our N and this is our P. I don't know if this is right for 5, negative 1. Oh! We're not in 3 space, so just assume we're in 2 space. Sorry about that. Thought we were in 3 space. So there. No harm, no foul. Okay. So those would be our this would be a rough drawing of it. I could do a lot better than that. 5 negative 1's over here. I'm sorry. Build a bridge, get over it. Okay, so what are the coordinates of N? Yes? Well, N would be, it's on this line. The X coordinate is going to be 1 plus t times 3 or 1 plus 3t. Similarly, the Y coordinate is going to be 2 minus t. Okay, and P is at 5, negative 1. Okay, so we need the vector Pn, yes, because we need it to be perpendicular to this line. Okay, so we need the vector Pn. Okay, and that is going to be, let's see, 1 plus 3t minus 5. So 1 plus 3t minus 5, and then it's going to be 2 minus t minus a negative 1, so that's going to be plus 1. And then, lo and behold, we get the wonderful vector 3t minus 4. And let's see, negative t plus 3, is that right? Or 3 minus t. I guess we don't like to have the negatives first. So there we go. Okay. Now, we need Pn to be perpendicular to this line. And how do we find that? Well, we're going to use the directional vector because it needs to be perpendicular to this direction, if you want to think of it that way. So we need it to be perpendicular to the directional vector b, which in this case is 3, negative 1. So we need it to be perpendicular to well, I should have it a perpendicular here, perpendicular to 3, -1. And the reason I had that dot is I was thinking a bit ahead. That means the dot product must be equal to 0. So I go over here, and that means that 3t minus 4, 3 minus t, dot 3, -1 must be equal to 0. So we work some things out. So let's see. 3 times 3t minus 4 plus, well, that's going to be minus, so because of the -1, so -1 times 3 minus t, and that must be equal to 0. We do little algebra here, and we get t, you have to trust me on this, equal to 3/2. Okay? So when t, assuming maybe it's time or whatever, is equal to 3/2, that's when it is perpendicular at point n. So find exactly the shortest distance. Okay? Well, now I have to find vector Pn, right? Now that I know what t is. And I'm just going to replace right here, t equals 3/2. 3 times 3/2 minus 4 is equal to 1/2. Okay, so that would be 9/2 minus 4 is equal to 1/2. And then let's see, 3 times 3/2 minus t is going to be equal to, I'm sorry, no, 3 minus 3/2, what an idiot I am. 3 minus 3/2, that's equal to 3/2, oddly enough. Okay, so the shortest distance is going to be the magnitude of this vector. So the magnitude of vector Pn is equal to the square root of 1/4 plus 9/4, which is equal to the square root of 10/4, which is equal to root 10 over 2, and we don't have any units, so we would say root 10 over 2 units. Okay, I'm going to cut this video off at the first example because we're at about 7.5 minutes, and then we'll do the last 2 examples on another video. I am out!